Hey, Southfield likes math and history, and we're gonna look at the rules of exponents part 2. So, in the previous video, we have been looking a lot about more rules about exponents, and that was the product rule, power rule, the powers of zero, and negative exponents. But there are 2 more rules that we're gonna look at. One is the quotient rule of exponents, and 2 is every number has an exponent. So, let's see what the rules are. Let's first see why every number has an exponent. So, if you ever solve these kind of problems, what happens if you're brought up with 2 being multiplied at by 2 to the second power, multiply that by 4 cubed? So how do you find the answer? Well, the rule clearly states that every number has an exponent. And if you have the number 5, for example, that is the same thing as saying 5 to the 1 power, because 5 times nothing is 5, or it's just itself. 5 is also just itself. So, when we have 2, we could say that we could have 1, 2 to the power of 1. That makes it easier for us. So, what we want to do is find an exponent and find the answer as our answer. So, since these 2 are basically the same, we can use the product rule and add these 2 exponents together, so we get 2 to the third power. Then we multiply it by 4 to the power of 3. The last thing we need to do is put these in number form, because this is different than that. So we're going to say 2 times 2 times 2 is going to be 8. 2 times 2 times 2. 4 times 4 times 4, that's going to be 64. So when you multiply the 2, you get 256. That is what you do when you see a number without an exponent. You have to give it an exponent, because every number has to have an exponent. Here's another example. Imagine you have 4x to this 10th power, but it's in parentheses. You basically use the same thing. Oh, and we have a squared, the second power. So that 4 needs to do something. We are going to put it as 4 to the first power, because 4 is the same thing as saying 4 to the first power. Now we can use the power 2 rule and multiply this by 2 and multiply that by 2. Just the exponents, not the numbers. We will get, multiply that by that, multiply that by that, 4 squared, and we also have x to the 20th power. So 4 times 4 is 16. No more exponents. So 16x to the power of 20. That is our simplest form, and that is our final answer. And those are scenarios why every number has to have an exponent. Let's move to the quotient rule of exponents. So, the quotient rule of exponents is actually another strategy that can shortcut you to get to your answer. It's basically the ones that we have been learning in the last video. So imagine you have 10 to the 7th power being divided by 10 to the 3rd power. What we could do is put them in its number form. So we're going to write there are 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Being divided by 3 zeros. 1, 2, 3. But that is a little bit hard to do when you divide them. There's actually a secret hack that we can do. When we are dividing, we could actually subtract the 2, because 7 minus 3 is 4. 10 to the power of 4. But how can we visualize that? We will extend this and extend that in its expanded form. So we're going to write 7 zeros. 1, 2, 3, 4, 5, 6, 7. Divide that by 3. 1, 2, 3. And when we cancel the zeros out, this one's now just 1. But wait, there is 1, 2, 3, 4 zeros. So we're going to write 10 to the 4th power. So when we divide exponents, we're basically minusing the 2 because we're trying to get rid and cancel out of how many you-know-what or numbers there are. It doesn't just work for tens. Let's do 4 to the 8th power and 4 to the 6th power. So we have to write 4 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And they're all being multiplied because it's saying 4 has to be multiplied by itself 8 times. We have to put a divisor symbol. Then we write 4 6 times. 1, 2, 3, 4, 5, 6. And when we do that, we have to multiply them. Let's cancel out. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There are 2 4s left. So we have 4 to the 2nd power, or 8 minus 6 is 4. There is a rule that we can visualize that will help us, that when you have x to the power of m, divide that by x to the power of a different one, or that can be the same. That's the same thing as saying x is going to be in parentheses your first exponent, subtract that by your second exponent. So, cha-ching, we have another shortcut. And that is how we find and understand the quotient rule of exponents and why every number has an exponent. Why do we learn exponents in the first place? Well, exponents are really, really helpful because in the 1500s, there was a banker that had to write the same numbers over and over and over again. But when he invented the exponent, like 4 to the 6th power, he realized that he doesn't have to write 4, 4, 4, 4, 4, 4, 4, 4. All he could do is write a tiny number on the top, and that indicates how much they need to write that number for. Because what if we want to write the number 10 to the 20th power? Let's do an expanded form. So 10 times 10 times 10 times 10.
2 hours later. Meanwhile, 8:01 p.m.
Finally, we are done. We wrote 20 tens being multiplied. So that is a number with 20 zeros. And trying to write it out in its expanded form takes way too long. So that's why we need exponents. And a tiny number has a giant effect. It saves you a lot of time. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe!